want to learn biology after 10 years? I didn't see any hands. And the second question was, how many bioscience students want to do, learn pure mathematics after 10 years from now? Only one or two. So all of you have to change yourselves, okay? Our discussion today is, this is the arrangement. First, I will tell you what is research, and then I will share something about my research. Actually, I will share some data from my PhD research work, and then we will go into the interdisciplinary nature of research, followed by I will ask few more questions from you at the end of the lecture. Okay? Okay, now what is research? Can you answer this question? Okay, before this research, do you know what is science? All of you are doing science. Do you know what is it? Huh? Okay. To me, science is the way of, thinking that, the correct way of thinking. Okay. Now, science is knowledge, and as long as you think in the correct way, you can see, feel, touch, and even taste science. As long as you just want to learn your biology or mathematics or whatever only through your books, then I think you can't go, your career will stop maybe after 6 years from now. You may become graduates, but you are not creative then. Okay? Now, research is the creative part of science. You can learn science, but how to practice it, it is by doing research. Now, this word, if you break it from here, okay, research is research. Look at something again and again. If you look at something many times, you will see it in many different angles. Okay? Now, there is a saying, discoveries cannot be planned, they pop up. So you can't plan some of the things. Of course, when we are doing research, we first do a plan. We set some goals. Okay, say for example, when I was doing my PhD, my professor asked me to design or develop a novel technology, new technology to treat special kind of water. It is called ballast water. I will explain you later. To treat it. So now, I have to think what I am going to do. So of course I have to do a plan, but generally you can't stick to that plan throughout your research work. Okay? Sometimes you will see very interesting things, and if you throw them away thinking that may be wrong, that may be the end of your story. So you can't plan each and every step, and sometimes you will find new things accidentally. I think even Dr. Dieters talk about that Newton and apple, the old story, and sometimes you may have asked about Archimedes and that huge water bath. Okay? So those are not planned discoveries, but they have turned the world, the path of the world, they have turned it. Okay? So that is research. So you have to change your mind from what you are doing now. Now what you are doing maybe, I don't know, you may stick to your lecture note or your tuition class or the tutorials and all those things. You may be doing lot of tutorials. I can remember when I was doing my advanced level in physical sciences, we did that two math subjects, like not like you, pure maths and applied maths. So I can remember sometimes under one team I may have done 100 or 150 to 100 sums. maybe some of them are just differ from numbers. Okay, if you substitute different numbers, you can make lot of questions. But that is not science. Okay? So you have to think in many different ways if you want to do research. Okay? You have to be very creative. Now let's move on to the qualities of a good researcher. Here, this list can be even longer. Here I have few things here. Passion, patience. Now, sometimes when you are doing research, you have some pre-planned idea. Okay, you think if I apply, say if I put this chemical into this one, the color should be blue. But when you mix two of them, you will see green. So now what can you do? Just throw away the solution and give up. Then go on to another experiment or change your research theme. Okay. Now you can't do that. You must have lot of patience and you should be persistent. Okay, you should. Now these three qualities, first three qualities are very important. And the fourth one, curiosity. Now this one, I think along the life cycle, your curiosity dropped down. Can you remember when you were a child, how curious you were? Can you remember? How many of you have break your toys just to see what is inside? Can you see that? I mean, can you remember that curiosity? I don't think now you have that. I mean, for most of the cases. Your curiosity is dying. Okay? Now, you have to change this. You can learn from your, say, sometimes from your nephews, nieces, and from those people. Now, how to be very curious. They ask many questions. When a small kid, sometimes even my 1-year-old girl, when she, sometimes she look at her toy and try to open up. Okay, so I help her to open it up and look inside. And if sometimes 2-3 years old girls and boys, they look at small creatures and try to understand what is happening. Now what had happened to you? Now you don't have time even to look around. Okay, you are only like looking like this, reading and reading the same lecture note, same class note for 100 times, and your curiosity is dying now. So you have to change that one. Now all these three words, skepticism, challenging and questioning, all represents the same meaning. Okay? So you have to ask questions not from your tutor, sometimes from yourself. Now for example, sometimes when you are doing that organic chemistry, I can remember when I was an advanced level student, we had to find that pathways starting from one molecule, go to another one, how to fill the blanks. Now most of the students were not good at that. Why? Because you are not asking questions from yourself. Why you put this, the second molecule there, what is the reason? Okay, so you have to start questioning from us, from your school teachers, from your friends, from your parents, and from your, from anyone, including yourself. Then the creativity. Now, what I can see is creativity is the next quality. Which you now, if you think about the creativity when you were a school kid, grade 1 or 2, you were very creative. Sometimes you draw very nice homes. Okay, sometimes upside down. You think, why can't we construct it upside down? Okay. But now, what is happening to your creativity? Think, okay? And if you think you are still creative, good. And if you think now you are not creative, start working on that. Okay? And scholarship. Now, this word, if you just listen, scholarship. In Sinhala it is Shishatva, right? I don't know, sorry, that any word I don't know. Now, scholarship. Now, it is something like giving you some money or some aid by some other person for you to carry out further your studies or things like that. But here scholarship is bit different from that meaning. Scholarship is the researcher must have this quality. The meaning is you should start narrowing down your work to some point, and you should start working on that point, and you should master it. So that is the meaning of that. Okay? Focus. You have, even in your advanced level studies, you have to be very focused. If you think about this and that, then you won't be able to concentrate your mind. Then you won't be able to even pass your GC advanced level. Then how can you become a researcher? Okay? Then you have to, you should be very, you have to attend to details. Sometimes when you see an experimental result, some people will see only one reason for that, whereas some other person can see 10 or 100 reasons for that particular data. Okay? Now let me tell something about I use our research work here because though I was the key person, there were a lot of others around me to help in this project. Okay? Now, before that I should tell something about me, just for you to realize how much you have to learn after your advanced levels or O levels. Okay? 15 years ago, 1995 December, I did my O levels. Okay, I was reading lot of things, including many novels. Then moved to advanced level physical sciences. As I can remember, I didn't have enough time to read many novels then, but I worked a lot on numbers, combined maths, physics and chemistry. Then University of Peradeniya, BSc in Civil Engineering. BSc in Civil Engineering. Now, civil engineering. How many of you know about this subject? In civil engineering, I have learned a lot of theory of structures, strength of materials, transportation engineering, how to build roads and structures and those things, and something about water. So after I graduated from the University of Peradeniya, I was fortunate to enter the National University of Singapore for my PhD studies, and I changed my subject to environmental science and engineering. Okay? From building works, I changed to environmental science and engineering. So now that is the first point. I changed myself from a normal civil engineer to environmental engineer. Okay? So this was a very huge challenge for me. Now I will tell you about my research, just to show you how interdisciplinary it is. Now the motivation behind our study was, have you seen ships? Have you seen them? Okay. Now these ships, if you have cargo inside, now I think you all of you are learning physics, very simple physics. Now you can keep it balanced, but after you remove this cargo, what will happen? Now do you want